All right. So here's what's on the agenda for today. Today we're talking about infinite series. Today we're talking about infinite series. You know, what do I mean by infinite series? I mean, like, do you see how I've written out a series of numbers? The difference between a series and a sequence, by the way, is a sequence is just numbers separated by commas, and series they're separated by addition signs. In other words, you're adding. So in this particular instance, you see how I do dot, 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 and I don't put a number on the end? It means that keeps going forever. You could do it by subtraction because essentially subtraction is just adding a negative. And if you wanted to try and, you wouldn't be doing it by division, no. That's what do you mean? Instead of the multiplication symbol in between? Yeah, nope, we're not going to be doing it that way. Nope, no multiplication. Nope, series is just a number separated by addition, but how you get from number to number can vary. You know what I mean? We could be multiplying to get this next number, and that would produce a geometric sequence if we were always multiplying by the same constant ratio. Or you could be adding, like in this particular case, to get the same number. What am I adding by? Good. So it turns out if you have an arithmetic series that goes off to infinity, never ends, do you know what the sum is? There is no sum. Just because you could just always add on another number. You know what I mean? Okay. And this is what I love. This is what really got me turned on to math. It's like philosophy of math. It turns out if you have a geometric series, that means we're multiplying to get from this term to this term. In some instances, even though you're going off to infinity, it approaches a number. It approaches a number. Let's think about it. Yesterday we learned how to add these up using a formula. In order to use the formula, though, we have to know r. What's r in this particular case? Times by a half. Right? We are multiplying by a half in every single instance. Anybody remember the formula we learned yesterday? It is the one that's written on the board to my right. So there were two versions of it, though. Right? One of them everybody kept choosing, like the first term times 1 minus r raised to the n divided by 1 minus r. But that could also be rewritten how, Dan? Sure. Yeah, order of operations matters. So let's try and fill in this formula as best as we can with the information we have written above, and then we're going to look to see what happens. Okay. So what was the first term in this particular sequence? First term was a half minus 1/2. What's the common ratio? 1/2 raised to the n. We're going to say it's not going to stop. All divided by 1 minus a half. And here's what we got to think about. What happens as we go to infinity? What happens when n becomes absolutely stupidly large? Think of a really big number. What's a really big number? 10 million. Could you imagine what a half raised to the 10 millionth power is? Seriously. Try and think of that. I mean, it's ridiculous.
It starts to overflow.
Yeah. You know what that... As n goes to infinity, what happens to this term in our formula? Overflow. But we've got to talk about what that means. I know your calculator said that to you, but I'm not sure what that means. It's too big? Or maybe it's too small? Maybe there's too many numbers. What does overflow mean? Not sure. Look, since it can't deal with 10 million like you've tried to plug in, let's try plugging in something, I mean, really much, 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 much smaller. Like, for example, instead of it being 10 million, I'm simply going to raise 1/2 to the, pick a smaller number. Larger than 5. Let's go less than 100. Okay, 1/2 to the 50th, right? You agree, that's not even big. Do you know what that is? That's e to the negative 16th means you take this decimal place and you shift it that way 16 spaces. It's point 0.0000000000000000008. 88168. Do you get what I mean? So did it become smaller or bigger? Ridiculously small, right? To the point where as n becomes big, and I'm talking like 1,000, 10,000, this thing over here essentially shrinks down to be what?
0.0006.
So what is it becoming closer? What is it converging towards? It's converging towards 0. Whoops. This converges to 0. And so here's what you're left with. If that converges towards 0, you get 1/2 minus 1/2 times 0 all over 1 minus 1/2 is 1/2. And so that's just 1/2 over 1/2. And 1/2 divided by 1/2 is what? How crazy is this? That the sum at infinity equals 1. Infinitely many numbers being added, and they approach a single solitary number. Skolnick just asked, is this going to happen every single time? And it was a great question. Because here's the moral of the story. If you have a geometric series and it turns out to be infinite, then as long as r, the ratio that you're multiplying is between 1 and -1, in other words, it's a fraction smaller than 1, and also bigger than -1, then it will converge towards a particular number, because every time that fraction gets multiplied by itself, it shrinks smaller and smaller and smaller to a point at which you would be adding essentially nothing on. You'd be adding something so small, it really wouldn't even change the sum that you already had. Do you know what I mean? And so you would approach a number. Dan the man? So, hold on one second. Hold on one second. So here's the deal. So like if it indeed converges towards a number, then you can just use this sum formula instead of this one, because this thing over here becomes 0 and cancels this term out. Okay? But if r is greater than 1, or it's less than -1, then the thing inside the parentheses, as it multiplies itself, will actually grow, and the sum will be infinite, and you won't be able to calculate it. Okay, so now we're going to practice this idea. This is a very rare question on your Regents. It's super, super easy, but it is rare. Okay, so let's practice. So let's do number 1. Teddy, what'd you say? You know, the problem is that geometric sequences, we can't really talk about them in terms of dividing. So if we're dividing by 3, what's that the same thing as? Very nice, yeah. Dividing by 3 is the same thing as multiplying by 1/3. So the sequence is geometric, and r is 1/3. So does it have a sum? Yes or no? It definitely has a sum, and we're just going to use the formula. The sum, as this thing goes to infinity, is, anybody remember it? So it's going to be 6 over 1 minus 1/3, which is going to be 6 over 2/3. 6 divided by 2/3 is 9. And that's the sum at infinity. Crazy, right? This thing goes on forever, but the most it will approach is 9. That's the limit. So that's the sum. Let's do problem number 2 and see if we could solve this one. What kind of pattern is emerging here? Times by 2, times by 2. Okay, I'll go with that one. Other people might said, okay, it's like plus 2 and plus 4. Whatever the instance is, suppose this is geometric, and the ratio between the numbers is 2. Will it converge towards a number? No. So the sum at infinity will be infinite. It'll just grow ridiculously large. Well, this one looks pretty bad. This one looks pretty bad. Let's just try and write out a few terms and see if we can't pick out a pattern. 8/5 to the first, 8/5 to the second, 8/5 to the third, all the way off to infinity. Ay, ay, ay. Yeah, so this is a geometric sequence series where r equals 8/5 because you keep multiplying by 8/5 to get the next successive term. 8/5 is 8/5 bigger or smaller than 1? It's bigger than 1. 8/5 is greater than 1. So s at infinity, the sum at infinity, is infinite. All right, let's do question number 4, and then we're going to get out of here. I'm going to put your homework up. So let's decide. Let's take a look. Does anybody see a pattern going on here? Okay, times a fourth. So that must be the r. R is going to be equal to a fourth. So does the series converge? Yeah, it does. It will converge. And so if it does converge, then all you have to do is use this formula. It's going to be 80 divided by 1 minus a fourth. We've got to figure out what that is. The answer is we get 320 over 3. Yeah. And so here's your homework for tonight. You got 4 problems, and that's it. See you tomorrow.